So, sorry I don't speak Czech. I'm going to do it in English. Good morning, everyone. Thanks for coming, and warm welcome also from Altair. I would like also to thank the whole advanced engineering team on behalf of Altair for organizing this event. So thanks again. It's always a nice opportunity to come to Prague. I hope you can hear me well. You also on the back. So in this time slot, I'm going to talk about the first pillar that we have from the slide that Hinek showed, Altair HyperWorks Design and Simulation Platform. But before doing so, let me first introduce myself. My name is Panos Natsiavas. I come from our office in Thessaloniki, Greece. And I also bring with me together two more colleagues. And we also have Simon from Bubligen. So I hope also with the team from Advanced Engineering, we're a small group to connect with you also in the breaks. If you have any questions, if you have any worries, any concerns, any complaints, we're here to listen to them. So I hope we can connect maybe later on. We're here for you. So in this slot, I'm going to talk, as I said, for the first pillar of Altair HyperWorks, and I'm going to show some of our new developments. Hinek showed this slide, but let me also say a few words. He did it on Czech, so I didn't really understand what he said, but Altair operates in these three pillars. So this is the heart of Altair. So we started with simulation back in 1985. So we have the first pillar that is called Altair HyperWorks, and it contains now all the simulation tools from pre-processing, solvers, post-processing, and so on. Of course, as you know, the products became complex, and we have multidisciplinary approaches. The simulation became pretty heavy in terms of computational power. So we also invested, and we also have tools and solutions in the area of HPC, high performance computing. So now I'm going to introduce to you the second pillar that we have. It's called Altair HPC Works. Here we leverage the computational power of the hardware and also some from the cloud. And lastly, the third pillar that we have is called Altair RapidMiner. Here it's a comprehensive data analytics platform that contains and leverages the power of data analytics, machine learning, and artificial intelligence. All these three pillars are not independent of each other. They all collaborate, and we have different use cases that may leverage all the three pillars. So we may have a use case that it's simulation. So we send it on the cloud to leverage the cloud compute, and we also use some AI in it. So we have many different cases that leverage all the three pillars. And all these three pillars converge to a solid base that is called Altair One. Altair One is our cloud innovation platform where we build and deploy intelligent products into the market in a collaborative fashion. So in the center, we have Altair One. So today's focus is going to be the first pillar, as I said. So I'm going to talk about the simulation part. And here I'm listing some of the benefits. Of course, since we're talking about simulation, with Altair HyperWorks, we're trying to reduce design iterations and to build physical prototypes. That means reducing cost of the company. Also, we're trying to empower large exploration of design solutions by having dedicated ribbons and workflows for optimization and design of exploration. Also, we foster innovation with our tools, and most importantly, we help engineers and designers to talk the same language. So we help companies with many team members to overcome the different silos and to have all the people working together and having access to different tools that they can learn pretty easy and they can solve their challenge. So this is the agenda for today. I'm going to talk briefly about our modeling and the visualization techniques in the beginning and the consistent workflows that we have and we connect with our broad portfolio of solvers across multi-physics solutions. Also, on top of that, how we leverage optimization to accelerate processes, and how we also, nowadays it's a trend, how we are pushing and we are enabling solutions and augmented solutions by using AI, artificial intelligence, and machine learning. And last time, we're going to close with some news about our cloud and our Altair One solution. So Altair, if you may know, offers a big variety of tools from concept design to validation, exploring multi-physics analysis. So one can use different tools to build the model, to build her model. So we have Altair SimSolid. Sorry, so we have Altair SimSolid, our revolutionary meshless solver. We have Altair Inspire that we call is a simulation-driven design platform because it's like the simulation in early stages of design that really drives the product, drives the design of the product. Then we have Altair SimLab, which is used for multi-physics analysis. And lastly, our flagship product for detailed modeling and validation, Altair HyperWorks. And here I'm going to also spend some time introducing the new GUI that we have, the new product that's called Altair HyperWorks. So as I said, based on the design time, based on the profile of the people, of the person, we have the right tool for you. So for designers, when you are in the early stages of design, we have Altair SimSolid and Altair Inspire that you can use in the very early stages of design. It specifically targets a little bit, not so much experts in finite element analysis, but let's say designers, that they are just starting the first steps with the simulation. So it's an easy GUI, easy to learn, easy to use. Then, for part-time analysts and for people that have more knowledge, we have Altair SimLab, and we also here leverage multi-physics approach, so you can really solve a thermal problem coupled with CFD or with structural analysis. So it's very easy to use and easy to couple this analysis. And lastly, for detailed modeling, for complex designs, for big assemblies, we have, and for experts, for finite element experts, we have Altair HyperWorks. And the agenda also for today looks, it's built accordingly. So we have different people talking about our different products. So we have Simon, who's going to talk about Altair SimSolid and Altair Inspire. Then we have Spiros Tselikis from Altair, from the same office. Spiros will talk about SimLab and some use cases that we have engaging with multi-physics analysis. And also we have Martin, our colleague from Advanced Engineering, that is going to cover the new features in HyperWorks 2025. So let me also share a few things about what's our vision, for the future and how we're trying to shape our products. So our vision is to have a unified user experience across all different products. So we're trying to blur the lines between the different products. So we're trying to give the opportunity for someone that is using Altair SimLab for multi-physics analysis to take it and mesh it maybe in HyperMesh and leverage the extreme capabilities of HyperMesh in meshing. Or take it and do some rendering analysis in Spire Studio. So some of our products, they already look alike. They have the same GUI, let's say. But we're trying more and more with the products to have the same GUI. So our solution is really not to sell our products to you, to our customers, to our users, but really sell our solutions to your challenges. So we're not gonna, name products and stuff, but we're gonna name solutions to you because only thing that you care is how to solve the everyday problem. So this is, the vision and where we're trying to go. So one product, easy to use, easy to ramp up. So let me focus now on HyperMesh. HyperMesh has been in Altair our flagship product for more than 35 years. The development team worked tirelessly all these years to put some nice features and workflows that are well ahead the industry standards. So here you can see different looks of HyperMesh, how it was in the beginning. If you know the early photos, maybe be careful, it's going to show your age. So this is how we started and how we ended. So now is the time that we leave this on the past. This classic, let's say, HyperMesh, and we're moving to the new interface. So, from 2022, we're only having the new HyperMesh, and we believe that, with the new HyperMesh, we bring tons of new development and new experiences for our users. Of course, we're trying to make this transition, this migration, as seamless as we can. All the models that you had before, all the scripts that you may have, the processes, they remain unchanged, and and we are here for you to help you. We have tons of material online, tons of trainings. You can also ask for training on your dedicated specific needs. So you are not alone on this migration process. We are here to help you. So some of the new workflows, we believe that we have streamlined all the new tools with the new interface. So the big change that we had from the classic HyperMesh is that now all the ribbons are gone. So, sorry, all the panels are gone, and now we have ribbons. And the ribbons are in the logic of, of the KAE analysis, how it starts, from geometry cleanup, then how you move with the meshing, how you apply the boundary conditions, the loads, how you send to the solver, and also we have also some posting capabilities in it. So it follows the logic of the sequence of the KAE chain. Of course, we have drop-down menus that you can see. If you select a tool, then we have another menu below. We also have some help documents that explains what this functionality is doing, some shortcuts that you have. Of course, you have better view controls with the cube that you can rotate your model and have different views. And also, if you don't know something, you can click Ctrl+F and you can write it. So I'm going to use auto-mesh functionality. So you can really find it there and it will populate the corresponding ribbon and tool. So why we're doing this? Why we're changing from classic to the new GUI? So what's the motivation behind this change? As I said, the performance and the number of clicks is mission critical for us. It's very important to give you enhanced tools. But it's not only that. We believe that with the new HyperMesh, we have tons of new enhancement and new workflows. I have a slide that summarizes most of them, and I believe Martin will also share some news. Also, some tools, they have integrated artificial intelligence in them, so I will explain and I will show you the shape AI technique that we have, also the physics AI that is embedded already in HyperMesh, so you can really use it already. Also, we made it a seamless learning experience for new and veterans users. So it doesn't matter if you are new to HyperMesh or you are used to the classic one. The trainings that we have, you can really get up to speed with a couple of hours training for 3-4 days, and then you can be independent. And as I said, we're trying to have this unified GUI, so we're trying to complete a congruent user experience and have the look of all the products to be the same. And also, we're moving towards, because we see that most of our customers are dealing with multi-physics analysis, we are also moving on this road towards cloud, towards collaborative work and multidisciplinary solutions. So this is, as I promised, some of the new features that they are coming with the new HyperMesh. So as you may know, HyperWorks has different clients in it. So we have HyperMesh, we have HyperView, HyperGraph, MotionView, MediaGraph, we have different clients. And we have features dedicated to new features to each of these clients. So for all clients, we have the view cube that I said, it's very easy to handle the model, the tool belt. We also have the dark theme. This is a very wanted feature. Now you can use HyperMesh and have dark theme on the background. For HyperMesh, I'm not going to go through all of them, just to name a few. We have a new workflow design explorer since a couple of years now. It's not pretty new, so it's from 2021, I think. For design exploration, I have some slides later on I'm going to show to you. We're also trying to connect the post-processing world with the pre-processing, so we brought HM Post in the HyperMesh, so you can really see some results while you are pre-processing by leveraging the HM Post ribbon. And also for HyperView, we have upfront loader, so you can load the result upfront in order not to wait ages to load the model. The hotspot finder is a pretty nice feature that you can spot all the red areas pretty quick. And also some new features for HyperGraph and MotionView. I'm not going to go through all of them. So now moving on to our solvers, all the previous, SimSolid, Inspire, SimLab that I said, HyperMesh, they are seamlessly linked with all these solvers. And we have, as you see, different areas that we cover and we simulate. So we have solutions in the control systems. We offer solutions in the manufacturing world by having, Inspire Cast, Mold, Inspire Extrude, all these Inspire platform solutions. We are also having solutions in the world of vibrations, acoustics, explicit analysis with radios or with OptiStruct that I'm going to show, for crash analysis, for blast, heat transfer phenomena, CFD, fluid dynamics, and also some electromagnetics applications and electronics. So you see a variety of different solvers here that are seamlessly linked with our modeling and visualization tools. So given my background, since I'm a mechanical engineer, I forgot to mention in the beginning, and I'm more on structural analysis, here I have focused a little bit on our structural solvers, on Altair SimSolid, OptiStruct, and Radios. So I'm going to show some features and a brief overview of each of these tools. So I'm going to begin with our what we believe it's going to, a breakthrough. It's a revolutionary SimSolid, which doesn't have mesh. You don't need to, you just import CAD. No geometry simplifications. You don't need to spend hours on meshing. It uses a pretty much same theory as the other solvers. It's an external approximations, finite element method. And you can have results in really, it doesn't matter how complex your design is, you can have results in minutes. So I recommend to you, if you haven't tested it, it's really an eye-opener. Of course, it gives you accurate results, but the nice thing about SimSolid is you can learn it in a couple of hours. So it's a very easy GUI, easy to use, easy to learn. The development team has worked tirelessly. Since we acquired this tool from 2018, we have 20 plus major releases, so we're moving and putting many functionalities in it. We have two flavors of SimSolid. We have the SimSolid app, standalone, that you can download and use, and we also have SimSolid on the cloud. So it's a web browser application, so you can use it on the cloud. And just to name last development that we did, we integrated an eCAD, electronic CAD reader in SimSolid. So this opens the road for not only structural analysis, but also for some electromagnetic and some electronics simulation. Moving on to the second structural solver, Altair OptiStruct. Altair OptiStruct is our industry-proven software solver for linear and non-linear analysis under static and dynamic loading. If you compare it with the Nastran, the open source Nastran, the linear solution is pretty much similar. It's an enhanced version of linear analysis in Nastran. But since 1992 that we started with OptiStruct, again the development team transformed OptiStruct to be a fully featured solvers. And now we can solve nonlinear phenomena, we can solve heat transfer phenomena, fatigue, vibrations, and lately we also integrated some explicit code. So now we can solve some phenomena using explicit timescale, like impact, phenomena of impact, and some drop tests. The benefits of OptiStruct is that you can have one model and you can have one solver for different analysis. As I said, you can solve the same part, for example, from the perspective of fatigue, for the perspective of heat transfer analysis, for nonlinear phenomena. So you can have different simulations. It also has embedded optimization, so you don't need to open another tool, another product. You can leverage optimization in OptiStruct. And it's also, some parts of the codes are parallelized, so it's high scalable, and you can run it in multiple cores. But let me focus on the latest development of the explicit analysis. So it's 2 years now that we have developed a new solution in OptiStruct, explicit. It's not the same as Radios. It's a totally new workflow that has all the standard analysis capabilities. And the most important is that lately we also introduce a single input file with implicit and explicit subcase in it. So you can start with implicit analysis, and when the time step is becoming really small, you can change to explicit analysis. So it's implicit-explicit continuation subcase, and this is in one input file. And of course, again, some part of the code is parallelized, so you can gain speed. And here on the right, you can see some different applications like a drop test that we solved with OptiStruct or an impact calculation. Regarding Radios, maybe you have heard that we also introducing an open source version of Radios. We call it Open Radios. it's also like now 3 years that we have opened it for the whole community. And here is the reasons why we did it. We followed this approach in order to democratize the use of explicit dynamics analysis, to maximize synergies between different institutions, universities, and industry, and to facilitate knowledge exchange and ideas. Everyone can go and download radios, open radios, it's free. But we have only this, let's say, restriction. It's not really a restriction. When someone develops the code even further, he or she has to, put the development back for the favor of the whole community. So if you made something new, we encourage the users to put it back for the favor of the whole community. So this is something that really will help go forward with the explicit analysis solution. Besides the open part of radios, which is just, I call it open radios, we keep Altair radios. This is a commercial version. It comes with the Altair license model. You can have the same support, technical support. You can ask questions. It has extensive Q&A. It's available, as I said, in Altair units. And of course, it has some maybe more capabilities like encrypted models for dummies and barriers, and some other material laws and stuff like that. So we have open radios that everyone can download. It's open source. And we also have another flavor of radios, the Altair radios, which is under Altair license. So now that I gave you all these different solutions, the 3 solutions that we have, let me put some perspective on when to choose which tool based on the engineering challenge that you have and the physics that you're trying to solve. So here I'm starting from this design to validation, the horizontal, this line, and from linear analysis and easy linear analysis to more multiphysics and nonlinear analysis. And here I have also another axis of what's implicit and what's explicit code. So SimSolid, it's on the left. It's accurate for design studies and a little bit of validation, and it's in the implicit code. OptiStruct covers a big variety, from linear analysis to multiphysics, implicit, and as I said, a little bit of explicit code for impact and drop tests. So for accurate and valid for validation. And of course, if you are really an expert and you want to perform explicit analysis and multiphysics analysis, then Altair radios is the way to go. So different solvers, different engineering challenges, different physics based on what you're trying to do. Let me move now to optimization. Regarding optimizations, really, we can brag that we are the experts here. We have optimization techniques since 1990. So we have been introducing topology optimization for 35 years now. And this optimization does not only affect, as I said, structural analysis, but also it applies to all these different solutions. So I have also, I've chosen some use cases, not only on structural, but on CFD, on thermal analysis that you can see. So our techniques are apparent with the products, with these 2 products, OptiStruct and HyperStudy. I have already talked about OptiStruct that has already optimization embedded in it, but we also have another tool that is called HyperStudy. I'm going to talk in a minute about it. So OptiStruct has optimization techniques since 30 years now, 35 years. We have 2 main pillars of optimization, let's say, the conceptual optimization. This really starts in the early stages of design, when you have some ideas on how the part will look like. And here we have 2 different optimization techniques. The topology, it's about where to place the material, and you can get rid of some areas that you don't need material. This is called topology optimization. And then we also have topography optimization. And this finds the best pattern. For example, if you have beads, especially in the doors of a car or on the hood of the car, this is just to have the best beads pattern in order to reduce maybe the noise. You don't want to hear the engine. So this is called topography optimization. And then, as you go further to the design, for better fine-tuning, let's say, we have a parametric and shape optimization. This is the second pillar, and here we have shape optimization. We can, change a little bit the shape and also the size. For example, about the thickness of each component. So different optimization techniques based on different applications that you are trying to solve. HyperStudy now, it's a standalone tool. It's not, as OptiStruct. You can download it from the Altair marketplace. Again, here you can leverage different optimization techniques. And here I'm listing some of the benefits. You can understand the design sensitivities, how some design variables affect the performance of the product, which parameters are important, find some trade-offs. If I change this thickness, what's going to be the performance of the part, the stress, for example, so you can find the best trade-off. And also the nice thing about HyperStudy is that it doesn't work only with Altair solvers results. So of course you can load results from Radios, from OptiStruct and Solid, but you can load results also from third-party software. So you can load results from different solvers as Abacus, ANSYS, and so on. Or you can have even your own code with Python. We have a very nice Python API that you can leverage and build your own optimization workflow. Being on the topic of optimization and design exploration, let me move a little bit and say things about our Design Explorer workflow. Design Explorer is a ribbon dedicated workflow in Inspire. We had it in Inspire, now we have it also in HyperMesh. What it is really an end-to-end workflow for quick optimization and results processing. So it's an easy GUI. You can identify your design variables. You can have an exploration summary to see the different designs. You can understand the effect of these designs into the part. And what's the nicest, the one that I find a highlight of this is the nice trade-offs that we have. These nice sliders that you can change on the fly. For example, if you define the thickness of the part as a design variable, you can make the part thicker or thinner. You can move it left and right. And the part on the fly, it approximates using AI and machine learning algorithms the new stress or the new strain. So this is a very powerful technique that we have, the sliders. And lastly, you can also, it is really good in terms of how you interpret the results. It does result categorization, and you can have some scatter plots and stuff like that. Another application that we have, now that I said we have different modules and different dots, and this is like an orchestrator. It connects the different dots. It's like a maestro. It's Altair Pulse. It's a new application that we have launched. It's like a low-code block. It works with block diagrams, and it connects, the KE chain. For example, if you are trying to solve a coupled FSI analysis, fluid structural integration, and you are using OptiStruct and AccuSolve, it can help you, bring HyperMesh, connect it with the solver, OptiStruct, AccuSolve, and then post-process the result, HyperView and HyperGraph. So in the first time, maybe it may take a little bit of time, but you can script, and then it comes very natural in the sequence when you have a repetitive process. So Pulse is really connecting the different products together, and it has this nice workflow from pre-processing, solving, analysis, and post-processing of the results. And now some optimization use cases that I have. Here I try to have different examples. So here I used for thermal and fluids. So here we used on the left, firstly, OptiStruct with AccuSolve, again an FSI topology optimization technique. It's about heating pipes and finding the best geometry of the pipes in order to maybe have the least amount of thermal expansion. So this is an analysis that is used topology optimization for CFD and structural analysis. Another application, it's a project we're doing with Mumbea. It's a pretty, everyone is going to benefit of that. The batteries, the laptops, everything has a battery, and how we cool it off in order, when we use it, not to have a very big thermal, very high temperature, is we're putting a cooling plate, and we're leveraging optimization with Darcy flow in order to have a better flow of temperature and not to heat up the device. So this is, again, a use case that we are doing for heat transfer analysis with structural optimization. And lastly, another use case is this time is in electromagnetics, e-motor. We have an electric motor, and we're trying to find the optimum shape. Here we're performing a free shape optimization using our flux, Altair Flux. It's our product for doing electromagnetics, low frequency electromagnetics, and how it connects with OptiStruct. And we're trying to maximize the average torque of the machine, of the engine, and also minimizing the ripple of the torque. So we're trying to find the best shape of the rotor magnets to do that, and this is a project that we're working on with Valeo, another OEM for automotive. Now, also, except optimization, on top of optimization, I have to say, we're also trying to leverage artificial intelligence and machine learning when it's of better use. So our techniques have, some workflows have AI in them, integrated in them. So why we should use AI? What's the added value with Altair AI? So first of all, what we're doing with Altair AI is that we're trying to augment the already variety of tools that you have. So by having more tools, so we're trying to augment the toolkit of the engineer. We're trying to increase the productivity by getting rid of repetitive processes and when you're doing the same thing again and again. So we leave that for the AI, and we're trying to focus the human to focus more on the productive process. And we're also trying to capture more knowledge and have more leverage on the results that we're trying to find. So we have more documents and more results that make sense to you, and you are able to take a decision much faster and with better insight. So let me summarize all of the AI tools that we have, and there are many of them. So I've already talked about HyperStudy. HyperStudy is really not, I would say, AI, but it's really it's the pre-processing tool for AI, as it helps on the structuring the result better and finding maybe some outliers that they are not going to be helpful later on the process. And I think Spiros, my colleague, has a nice workflow about HyperStudy connection with physics AI. So he's going to explain how you can use HyperStudy to perform some physics AI predictions. Then we have Physics AI Studio. This goes with Physics AI, so you can really leverage Physics AI, but this is on the Altair one, leveraging the cloud. So keep an eye on this. Again, the Design Explorer that I have talked, which is a dedicated workflow for design exploration in HyperMesh and Inspire. We have the third pillar. This is a whole new solution that we have here, low, no-code data science capabilities that we have. I'm not a data scientist, so I'm sorry, but I don't have more than that to share. But we can connect you with an expert and explore more on this. And then the last three that I have some slides also I'm going to show, the Shape AI for geometry recognition. What Shape AI is doing is, again, a technique that is integrated in HyperMesh, so you have it in HyperMesh. What it's doing is it groups together similar shaped parts, so this helps you later on, if you want to make a change in one of them, to propagate this change very fast to the rest of the group. Physics AI that is leveraging some historical simulation data to perform some predictions. And also ROM AI that comes from the initials reduced order modeling, that is using some AI capabilities, that you can turn a high fidelity simulation into a reduced order modeling by keeping the accuracy and also reducing the simulation time. Of course, about Physics AI and ROM AI, my colleague Spiros Mallios is going to talk about this, and he has two different slots. So firstly for Physics AI, and then for ROM AI, and how it connects with the digital twin technology that we have. So this is a pretty interesting topic. So I'm going to show the rest of the things that we have. And here is a glimpse of how the products look like, the features look like. If you notice, except from RapidMiner, that is a different tool that I said, a different platform. And here we have AI Studio, Panopticon, we have different tools. HyperStudy is a standalone tool that I mentioned. Design Explorer, Shape AI, Physics AI, all these are integrated in HyperMesh. So you can really use it if you have enough Altair units, you can use it in no cost, and you don't have to download another app, so you can start using it right away. And ROM AI, I think you can invoke it by using the Twin Activate, another product that we have. But all these are, are tools that you can use, having again the amount of Altair units that are requiring. So this is how each tool is a glimpse of how each of these tools are looking. And let me go a little bit deeper and explain Shape AI. As I said, Shape AI, we have a dedicated ribbon under the assembly, the match tool. So here, you just have to click the parts that you want to find which parts are similar. Here we select the whole plane. And you see how fast it is and how it opens the subsystem assemblies and how it groups the parts all together. So for example, here, it grouped different parts together. On the left here, you can see. So let me isolate some ribs, and let's say that I want to delete some elements on this part. And I'm going to make a change. So you can go and sync later on, and you will see that this change is being propagated in all the other ribs. And here you have like 2 ribs, but you can have like 1,000 of bolts, of rivets. So when you do one change, you can really quickly propagate it to the other parts. And it's really good because it's not only working about finite element entities, it also works for CAD. So you can patch a hole here as well. So here I deleted some elements, but you can also perform some CAD manipulation. Going one step further, and again, using the technology of Shape AI, we have a new workflow that is called Classify. And this is how, again, you group certain parts together, similar shaped parts, but then you also go one step and you label them. So, for example, here I have a use case with the cars, but it works with any other, with airplanes with different assemblies that are similar. Firstly, you need to train the model. You need to put some parts that are similar. So you start by labeling the parts. So here I put a car, and I start with panels. The green are panels. Then I go and I label some windows, some tires. So HyperWorks knows what each part looks like. Then I load another car, pretty different, just to have to build up the amount that is needed for the training. Then I hit train, the second button here. And then I bring a new model that HyperWorks doesn't know, and I say classify. So now the software, because of the previous cars that I've put, now it knows, which part of this track are the panels, which are the tires, which are the wheels, and so on. Of course, how easy it is to train the model, it depends on how similar are the parts that you are training the software with. So be sure that you have all the different types of cars in order to, when you put something new, to be able, the software to recognize the different parts. But it's again a workflow that is leveraging AI. And again, I said that many times, but I want to highlight it. This is integrated in HyperWorks, so you can start using it right away. It's again under the same ribbon as Match, Shape AI, so it's under the assembly ribbon. And a few words about the rest of AI solutions that we have. Physics AI, again, I'm just touching this. My colleagues will go deeper. So Physics AI is a machine learning app that's using geometric deep learning and graphic neural network techniques and learns from historical simulation data and is able to predict the behavior of the part if you change something. It works on both meshes and CAD, so you can also apply it to CAD. You can just import geometry and hit predict. It leverages also some CPUs and GPUs, and we have it in HyperWorks since 2022.3. So this means a couple of years now. Another AI application that we have, and it's pretty interesting, it's ROM AI. Again, this application is a no-code application using artificial intelligence. And what it does, it translates the full model, the full analysis, the full high-fidelity analysis into a reduced order model that you can captures the accuracy, but also solves it in less time. So it's a no-code application. You don't have to be a data scientist or a programmer to use it. It's an easy GUI. I think the training lasts a couple of hours, 3 hours, and you can be independent. And also you can couple it with all these different applications that my colleague Spiros is going to talk about. So ROM AI has two flavors. Either you can use it as from high fidelity models to have the reduced order model, or you can also use it when you have experimental data, when you have Excels, when you have different data, from taste data to identify some parameters that are important. So it's also another flavor that it has is the system identification. And again, in both cases, it has very good accuracy, up to 98%. But what it really, the benefit is reducing drastically the simulation time. And you will see some numbers that my colleague Spiros has, and how it couples it with the digital twin transformation. So again, another interesting topic on that. And I'm going to close my presentation by giving you some hints and insights about Altair One that maybe you know. Altair One, it's a our cloud innovation gateway. You can register in altair1.com. You can sign up. It's a very easy procedure. You just have to put your email, your address, let us know which company are you from, and answer some questions. And then you can download our products. You can download documentation, some tutorials from the marketplace. You can ask for support from a dedicated support team. You can leverage our compute power, either our resources on premises or on the cloud. And you can also build and have your digital thread in Altair One. So different procedures, different benefits based on what exactly you are doing. And I'm going to close my presentation by giving some news. I think Hynek touched the point from the little Czech that I understood. But let me also share some news, some very interesting, exciting news, actually. I'm sure you all know that Altair is being merged into the Siemens family. So this acquisition happened blazing fast compared to our competitors. We closed it early, end of March, I think. So in less than half a year. So right now, we're in the phase of trying to integrate. Of course, we're big teams, big families, so it's going to take some time. Maybe we don't have all the answers right now, but what I can assure you is that with Siemens, with also their products and Altair, we're going to deliver to you a full suite of physics-based simulation portfolio. So, of course, you know that Siemens is strong in some areas, like computational fluid dynamics, maybe on some electronics. With the Team Center, they have a very good integration with PLM, product lifecycle. And then we are stronger in some other regions, like optimization that I mentioned. We have 35 years of experience with structural solutions, with electromagnetics, and so on. So together, we are one big family, and what we can assure you is the value that you're going to get, the support. This will remain unchanged, and this will become even greater now with these two companies coming together. So if you have any questions about this, let me know. We're trying to be as transparent as we can right now. Maybe we don't have the answers, but we may be able to guide you and answer some of your questions that you have. So really big news here. I'm also excited and very happy to be joining Siemens. So with this, I'm going to conclude my presentation. And I want to thank you all for listening and for your attention.